I'll see. I'll be watching. Yeah. Hope you're watching to be adjusting.
I think you share it.
I'll share it with you.
Okay. Good afternoon, everyone. Okay. We are coming to continue what we did last week, but first of all, I would like to give a recap of what we did last week. Last week, we learned something on Venn diagram, and then set theory, and then we look at Venn diagram in some examples. So let me give some small recap on what we did last week. Okay. Last week we talked about what set theory. We look at what an universal set is. We also look at, so when you say universal set, it's a bigger set that we are considering. The set that could be is called other subset. So basically that's the universal set. And then you have the subsets. So the subsets are the set that is contained in the universal set. So when you have something like this universal set U, let's say a set of all positive integers, say less than certain number, say 15. So in this case, our bigger set is a set of all positive integers less than 15. And then we have these two sets to be our subsets, say set of odd numbers less than, let's see, less than 5, less than 15, but greater than, let's say, 5. This is just example to illustrate what we did last week. And then we have this B equal to a set of even numbers. A set of even numbers less than, let's say, 10. So when you have this, then you can be asked to find okay. So when you have this problem, you can be asked to find A, F. You can be asked to find A intersection B. A union B. And what else? Okay, so let's concentrate on this. But before you can find all this, you have to know what an intersection is. And then last week, if you remember, intersections of A and B means the element appears in A at the same time in B. And then A union B means you are combining the elements in the two sets. So before you can find your A and B, you have to list what your universal set is. So first of all, ask yourself what is positive integer or what is an integer. So with that one in your mind, you know what an integer is. Then you list your universal set. So here, our integer start from 0, 1, 2, and then 3 dots. This 3 dot means it continues to say less than 15, so 14. So positive integers basically is whole numbers that are positive. And then you have a set of all odd numbers less than 15 but greater than 5. So what are the odd numbers that are greater than 5 or less than 15? So we start from 7. 9, 11, and 13. And B, we have a set of even numbers. Even numbers. Set of even numbers less than 10. So what are the even numbers less than 10? We have 2, 4, 6, and 8. So in this, when you're asked to find A intersection B, it means element that appears in both sets, A and B. So what are the elements that appears in both sets? Anyone with idea? So you check, is there any element in common? Do they have any element in common? The answer is no, because we don't have a number that is like behaves even and odd. They are distinct. So we have A intersection B to be an empty set. An empty set is represented as this. Either you have a curly bracket without anything in it, or we have this. So this is an empty set. An empty set. And then we have this A union B. That means we are combining the elements in these two sets. So that's what basically we did last week. And then we also look at what a Venn diagram is. Look at what a Venn diagram is. Okay. So I'll just give some small illustration about what a Venn diagram. So we can solve this one, solve that one, and then this one. So let's look at what a Venn diagram is. Venn diagram. So if you remember last week, we defined what a Venn diagram is, and then I gave you some examples of Venn diagram so problem to solve. Okay, so what do we want to do here? We want to write all these problems in a compact way by representing them in a diagram form so that you can visualize it well. So we have this diagram, and we take this box or this area to be our universal set, the space that we are working in. So we normally name it U. And then we have this, our subsets, A and B. So let's say this is our subset, A and B, A. And this is our subset B, other side B. Okay, so who can tell me why you have a disjoint set over here? Because we are not having the intersection. So when you look at this one, we have A intersection B to be an empty set. So we have this disjoint set. So if we want to represent our problem in Venn diagram, this is how it will look like. So first of all, we list all the elements in A. So we have 7, 9, 11, 11, 13, and then B we have 2, 4, 6, 8. And then the U will be the total space. So when you see something like this, A and B, and there's no common element between those two sets, then you have what we call a disjoint set. But when you have an element which is common between them, let's say this is A, this is B, then you have this. You have these two sets. These are U, let's say this is our K, this is our N. When you have two or any element between the two sets, then we have this section. This is the intersection. So this is the same as number of K intersection N. This is the meaning of this section. This is how it means. And when you look at this section, let me color it. The one colored, the one with this color, this region is what we call K only. That means we remove the intersection from it. So we have this one to be K only K. And then this one is this section is for N only. This one is for N only. And then when you find A intersection P, sorry, A union P, when you find A union B complement is the region outside the circles. So it means after finding your A union B, those elements that are in this set, they are in this set, but they are in the universal set, but they are not in this set. Right? That's the meaning of complement. So when you combine all the elements here, but they are here, but they are not in the universal set. That's the complement. So that's basically what we did last week. So today we are coming to solve more problems on Venn diagram, some practical problem. Okay. Okay. So why are we interested in Venn diagram? Because Venn diagram is we try to represent all these real problems that we are facing each and every day into a more simple and compact way so that we can easily visualize what we want to solve. Okay, let me give you this scenario. Let's assume that I am counting number of dog and let's say cat in each house, in every house, and then I've seven some number of houses, and then let's say these are the results that I have. Okay, so I've realized that I have in 18 houses have cats. We have a cat in their 18 houses have cats. And then let's say 14 houses have a dog, at least a dog, have dog in the house. And then 8 of them have both cats and dog. And then other houses, when we went there, you realize that none of them, so let's say 12 houses have neither dog nor cat. Either dog or cat, nor dog. So this is a problem that we are facing. So we now want to solve how many houses do we have, how many pets in all, like those kind of questions. But before we do that, we try to write this one in mathematical way so that we can easily solve it. Okay, so this is the problem. You have 18 houses have cats, 14 have dog, and 8 have both cats and dog. And then 12 have neither of them. So 12 have neither of them. Okay, so let's try to represent this one in a Venn diagram. So to have that, as usual, let's draw our total space. The total space here will be the total number of houses that we went through. And then we have two main classes. We have a set for cats and then a set for dog. So we try to represent those with variables so that we will not be writing dog, cat, dog, cat. Okay, so now let's represent, let A represent dog, let's say cat. Okay, let me do C so that, and then D represents dog. So when you come here, you draw your Venn diagram. This is a set for cats, and then this one will be for dog. So now we have this C for cats and D for dog. Okay. So here we have number of dog. So number of D is equal to, now we find later number of C. I want to find it later. But let's go through the problem here. We have 18 houses have dog. 14 houses have, 18 cats, 14 dog. And then 8 are both. So we have first this 8, this section represent both. Both means both houses. Both cats appears in both houses. Like those are both. So we have number of houses 8 having both cats and dog. Okay. And then what next? 12 houses have neither dog nor cats. It means those houses, they don't have cats. At the same time, they don't have dog. So this one comes under this 12. And then this 12 is A union D all complement. We'll give you this 12. Okay. So now, what would be the questions? What possible questions can emerge from this? Okay, now we want to find the total number of pets. So here we have cats. And then this place is 14. So we want to find a house. If you don't know this, this 18, this 14. Houses with cats only. This is a house with cats only. So this place means a houses with cats only. This place means a houses with what? Only dog. Only dog. So this is how you can represent this in your on your Venn diagram. And then when we want to know the total number of pets, total number of pets. Number of pets. What will be the total number of pets? So before you can answer that question, the pets that we are considering now is cats and dog. So you sum all this, and then this will give you the total number of pets. So total number of pets will be 18. Plus 8 plus 14. This will be total number of pets. This will be the total number of pets. And then, so you have total number of pets, this plus this plus this. And then total number of houses, and then you add all of them together. But the pets that we are considering is total number of houses. So our universal set now, the total number of houses is 7. It's 18 plus 8, then plus 14 plus 12. Because we have 12 out there, 12 houses without dog or cat. So this is basically how we represent it in a Venn diagram. But I'll give you more complete example on the Venn diagram by solving some BECE questions. So I would like to solve 1 or 2 questions that you may see in your course or BECE. So that's how we represent it. So anytime you see something like both, it means intersection. When you see something like or, it means a union. That A or B. It means union. So now let's take more concrete examples. So, okay. So I'd like to solve a person on the Venn diagram. So we have this one, it's 2015, 6, 1, 8. In a class of, I'm writing down the question, a class of 70 students. A class of 70 students. Right. In a class of 70 students, 40 belongs to Red Cross Society. Red Cross Society. I just checked it. And then 27 also belongs to. Some of them belong to GGS. And 4 belong to both society. So both society. 4 belong to both society. And the remaining students. Remaining students do not belong. They do not belong to. Any of the society. Any of the 2 society. So the first question is, illustrate this problem in a Venn diagram. Illustrate this in a Venn diagram. So we are coming to illustrate this one in a Venn diagram. But first of all, let's go through the question. In a class of 40 students, 40 belong to CRS, 27 belongs to DGS, and then 12 belong to both society. Then the remaining students do not belong to any of the society. So when you have a problem like this, you ask yourself, what's the meaning of this? When you say in a class of 70 students. So in a class of 70 students becomes our universal set, our total space that we are trying to stay. So solution. So let U represent our universal sets. We want to write everything in terms of symbol so that it will be simple for us. The total number of students. Number of students. So U now is our total number of students. That is our universal set. And then we also let say C or anything A. So let A be there. Let A represent those who to CRS. And then we have our B. Let B also represent those in GG. Represents the so now we have this, and so now we have this to be our two subsets, and then we have the universal set. So now the next step is to write out the important message or information. So with this, we have number of total students. So we represent it like this: N and then comma N bracket U. This total, that's how we write it. We represent it like this. It's equal to 70. This is the same as total number of students in the class. And then total number of students that belongs to CRS is 40. So you have this N a 40. And then you have this total number of students that belongs to GG. Then we use B to represent that. So we have this equal to 27. 27. So now we have this 12. You see, 12 belong to both society. So the two sets that you have is this A and B. Now we represented them by A and B. So when you say something belongs to both sets, it means its intersection. So we have total number of students in this society in this. So we have A intersection B is equal to 12. Is equal to 12. That's what this means. A intersection B equal to 12. And then you have the remaining students who do not belong to any of the society. That means they are part of the school, they are part of the class, but they decided not to belong to any of the society. And that one comes when you That's the remaining students. This one you are here to find it. Because these students are not part of the society, any of the society, but they are part of the class. So when you find the union, when you add these two societies, and then you find its complement, then you have the total remaining students. Okay, so now this is the extraction of this word problem into this more mathematical way. So after getting this, our first question is to draw or illustrate your information on a Venn diagram. So basically, this is what we've written. So I can name this one. We solve our first question. So the first question says, illustrate this in a Venn diagram, and then we know how to draw our Venn diagram. So this one illustrates in a Venn diagram. So in the Venn diagram, in Venn diagram. So what is our total space? So this box so these are total space, total number of people in the class. So U, it is equal to 70. So we are just transferring this information into the Venn diagram so that we can. And then we have first set for A, which is this. Let's assume that these are A. Then this are B. So we have A, sorry, we have A, and then total number of students that belong to the first society is 40. And then that of GG is 27. And then this means both. The intersection is the same as both. So A intersection B is for 12. So you have 12 over here. And then, so this basically how you represent this in the Venn diagram. So this is how we represent it in the Venn diagram. So the next question is, we have to find the total number of students that belongs to only A, that belongs to only CRS. Only CRS. Only CRS means only this reading. We are considering this reading. That's only A. So II. Only A. So we are considering this reading. Okay. But what do you know about A? The total number of students in A is equal to 40. And then we have this 12 here. So what you can do is, you can represent this portion with any variable. Let's say X. So let's total number of students reading only A be equal to X. So to find our this X, we just consider this set A. And then the total number is 40. So you have 40 equal to X minus 12. So by simple algebra, we have this. Because when you add this and this, you have to get this. So it's x plus 12 rather. So you have this equal to x. So 40 minus 12 will give us what? 40 minus 12 gives us 28 equal to x. So now we have 28 students belonging to what CRS. So here we have 28. So here is 28. So you have 28 students. Okay, so now let's look at number of students that belongs to. I hope I can clean this one. Okay, so now let's find for those only GGS society, those who belong to this society. And that one we represent it by what? A, B, sorry. Only GG, so these are set B. So we are talking about this section, only this. So you will take this whole set, and that one sum up to 27. So this one, let's represent this one by Y because we don't know what this one is. We are now coming to find it. So we have 27 equal to, let me put it like this. We have Y plus or 12 equal to 27. So now we have Y equal to 27 minus 12. We have our Y is equal to 15 students. So now we have 15 students belonging to only GGS. So we have 15 students. Only society. So this is how you should. After getting your 15, don't stop there. You have to interpret your results. So what's the meaning of that 15? That 15 is what? Students who belong to only GGS society. They don't belong to any of the other society. What they belong is only GGS. Okay, and then the next question is, we should find those students who decided not to belong to any of the society. So they choose not to belong to any of the society. They choose not to belong to any of the society. And what does that mean? What's the meaning of that? If you don't belong to any of the society, but you are part of the universal set, they are in the class though, but they decided not to join any of the society. So this is a total class, the total space that we are dealing with. And this belongs to A, this total belongs to B. But those students decided not to join any of the group. So where will those people fall in this space? Okay, so to know that, then you have to find the union of this whole set. And then the union in set theory is the same as addition. You're adding them. So you find the union of this, and then you take the complements of those results. So this region becomes all this region. Then the total number of students that are part of the class, but they decided not to join any of the society. So let's find the total number. So how would that be? So mathematically, we write it as this. Number of students do not belong to any of the society is the same as A union B, all complements. And complements in set theory is the same as subtraction, right? So to find this is the same as we have this set. This total space here is our universal set. And this complement is the same as subtracting the element that appears in both, that appears in the union of these two sets from the universal set. But this one we are dealing with numbers. So what is our universal set over here? Our universal set over here is u, which is equal to 70. So I can place 70 over here. So I have 70. And the complement is the same as what? Subtraction. So it is minus, and then this u. A union B. What are we doing? We are adding the elements, the number of students in that two sets. So what are they? So we add the two of number of students, number of A. So this is the same as number of A plus number of B only. So this is the same as number of A only and then number of B only. So the next step is we have 70 is our universal set. So this is how the formula is. To find the complement, you have our total space, total number of students in the class, minus number of students that belongs to A, plus number of students that belongs to B, minus the intersection. So with our scenario, what we have to do is you add this to this number of students within A only, which is 28, plus number of students who belongs to what B only, which is 15. We add 15 because this one has been taken care of. We've subtracted minus 12 from it already, so that's why we jump to this level. So now we have 70 plus 12, but this one, negative 20 positive. So this is the formula. So you have this. So 28 plus, so you add this together. So I guess you have something like 55. Yes, 55. 55. So you have 55. So now you have 70 minus 55, which is equal to 15. Equal to 15. So you have 15. So what's the meaning of that 15? The 15 represents number of students who decided not to belong to any of the society. So number of students that belong to neither of the society is 50. It's 50. So that's how you go about it. So when you have a problem like that, you just go through the procedures and then you come up with your answer. Don't rush, read through the question, make sure you understand, and then you write it using your set notations, and then you solve the question answer. Okay. The last thing that I will teach. So this is basically how it will be if there will be any question on Venn diagram. So this thing is very important. You can get some questions in both objective or in section A. So you have to understand what a union is what intersection is what a complement is, and then you have to apply the difference. Okay. So what I would like to say is try to solve more questions, more problems, and when you face some tough question, then you let us know. So you can drop a comment down so that we will attend to you. Okay, I would like to show you one or two important of why we are studying Venn diagram and what is the motivation. Okay, I have just a few minutes, so I decided not to solve the lesson. But let's talk about this. We are in COVID-19, right? And then everyone is in his or her house because of the lockdown. And then now the disease is spreading very fast. So there is this thing we call social distancing. So how did they able to come out that, oh, this is the best way to stop the spread of this COVID-19? I guess they use Venn diagram, right? Okay, so let's assume that we have our Venn diagram, this one. So this should I say community that we live in? So let's assume that this is a community that we live in. Let's say Tema, Grab, Kumasi, whatever. This is where you live, your hood. And then you have these neighbors. These neighbors. So let's use sets to represent neighbors. So first of all, I would like to represent just have three neighbors. So you have three sets, A, B, C, your neighbors. So you have this. This, let's say this is your house. This is Kwedu's house. And this is Ame's house. Right? So let's say this way, Kwedu is standing here, right? This is Ame. And then this is Kofi. And then we want to stop the spread of this COVID-19, right? So this is the same as social distance. You see, this guy is living on this part is on your own. Don't come closer to this guy, don't come closer to this guy. And then let's assume that two people have been tested positive and negative. They don't have the virus. Let's assume that this guy don't have, this guy also don't have. But this particular guy has the disease. And what is the meaning of this intersection? This is that intersection is telling us where they meet or interact. So let's say this is a gym. Kofi and Amma visit the same gym. And because Kofi is having the virus and Amma is not having. And one thing about COVID-19 is when you are infected, you wouldn't know until the 14th day before you try to show some sign. So you don't know whether this guy is having. But here he's having, but you don't know. And then you are interacting with this guy. So the probability that you also get the virus is very high, right? So that's why they say social distancing. Don't come to this session. So when this guy interacts with this guy will have the virus. But let's look at this. Okay, let's assume that this is the marketplace. This guy also visits the same place. Both of them don't have the virus. So when they interact, none of them will get the virus, right? But this guy and this guy can have interaction. So this guy will also get the virus, and then indirectly, this person will also be infected, right? So it's just like that. And this when you interact, when you come here, this intersection, there is interaction. And this is the common place both of them meet. So if this guy and this guy and this guy, they all meet here, then this guy will spread it at the same time to these guys. So that's why they say we should do social distancing. So if there is intersection here, then that means the virus will be spreading because we don't have any immunization for that virus. So if you want to solve this, then you have to have what? A disjoint set. A disjoint set. So this intersection. So you have this. So you now have this set. Kwedu is staying at home no interaction, no interaction. So let's draw it nicely in some sets. So we have this. So this one is social interaction. So you have this to be social interaction. So when there is social interaction, then you have what? The sets having a common intersection like elements. So this is social interaction. And we want to stop the spread. So what do you have? Social distancing. So this one becomes social distancing. So for social distancing, either the sets should be apart or everyone stay in his or her own domain without having any interaction. So you can have this scenario. You have this. This is the. This is this is Peru. So when you have this, then there is no interaction, right? So that's why there's lockdown. I don't know. That is basically. So stay at home. But you also stay at home. Now also stay at home. Then we stop the spread. But if we interact, then we will continue to have this spread. So this one is negative, negative, positive. So this guy is only positive quarantine, and then this person can be treated, so that these two people will not be infected. But when we interact, then this guy will infect this, and then this guy also can infect this. So it will keep on spreading. That's why like you should do some social distancing. And then if there should be interaction, then you have to stay at your home. This level. Don't interact. Don't come here. Right? So what I would advise is stay at home. Let's all help to stop the spread of this dangerous virus, because there's no immunization for this, and then when one person gets it, it can affect everyone. So you have to be very careful and then be vigilant. Stay home, stay alive, and then you are very important to your society. Thank you very much.